Wait, is it starting already? Okay. Hello everyone, my name is Teo Kailang, and today I am so excited to share about, maybe not too excited because I'm so tired now. I'm so excited to share about Parquet storage reduction to you guys. So in my previous story, in the SMJK Parquet, me and my friend go and visit Parquet ma. So one of the followers have mentioned that they wanted to see the actual tutorial of the storage reduction through Parquet, and today that is what I am going to do right now. So let me share my screen. Okay, I believe you can see the screen, and let's dive straight into it. So there's the problem statement of a imaginary company. Let's say you are a company, you're a CEO of the company, and you wanted to reduce the storage of, you wanted to maximize the storage value of your servers. Maybe you have a 220 TB NAS server lying around in your data warehouse or somewhere in your company, and majority of the files inside, majority of the data inside are consisting of CSV files, which is comma separated value files. So these are very structured data, and of course, you will want to store it in the way that maximize the storage value. So what you're gonna do is you're going to zip the CSV files into maybe a .zip folder or maybe a .7z folder. So compression and decompression takes a lot of time. And believe it or not, CSV files, I mean zip files or 7z files, might not be the ideal scenario when it comes to the data engineering, when it comes to a point of a experienced data engineer standpoint. All right, I'm just joking. Okay, the common compression format is, you can see over here on the screen, which if you do know how to use a laptop, you can just right click in for a file, and then you can click compress to. So these are the choices that appears, which is zip, 7z, and tar. So you can see I want to focus on tar a little bit because this is the only moment that I'll be focusing it off. So you can see over here, it is like, it's not compressing in the sense where it will reduce the size of the data. So you can see it is actually have a negative compression rate. So in my experiment below, I will not be comparing with using .tar approach. So let's ignore that forever. Next, you can see over here, let's focus on zip and 7z. So you can see over here, the compression rate of 7z is the better compression approach when it comes to converting CSV into a condensed format. So remember 7z. Next, I want to introduce you to Parquet. So what Parquet does is it will convert CSV files into a .parquet files. You can treat it like a super data frame, super DF. If my friends of data science, data analysis, data engineering are actually paying attention to class, matter of fact, it's not, if you're not pay attention to class, you will absolutely know what is a DF, which is a data frame, which is you need to import the pandas libraries, and you can manipulate data using pandas data frame. So what basically Parquet is that it will convert CSV file into Parquet, which I said before already, and it does not require decompression and compression. That's the beauty of Parquet. So if, let's say, a CSV files will need to be compressed into a zip file, and when you wanted to do data analytics, you will need to decompress the .zip file into CSV file and then extract the data and do the things that you need to do for prediction and whatnot. So by using Parquet, you'll just need to convert CSV file into Parquet, and then you'll just need to read using the function dot read underscore Parquet, and then you insert the file path that you want, and then you will just read the Parquet into a data frame. So all in all is to say Parquet is the better approach when it comes to a data engineering engineer standpoint, because it is a better storage reduction way than traditional way. It is a better compression and decompression uh, when it comes to compression and decompression. So because it completely remove the need of compression and decompression. So I have wasted a lot of time to explain the theory of Parquet. Actually, you can just refer to YouTube or whatever explanation, and maybe ChatGPT. I'm pretty sure it will have a better explanation than me, obviously. And yeah, let's continue with the slide, shall we? So common Parquet algorithms are gzip, snappy, broadly, ZSTD, which is a very good name, and LZ4. Okay, now let's focus on this broadly. I will be focused on this broadly since I already booked it with a good reason, which is explained in the next slide. So over here, you can see is the metric of storage reduction. So I wanted to rank which is the best algorithm of converting into Parquet. So which algorithm is the best? So it turns out Botley is the best algorithm. It can turn a 100% CSV into a 8 to 9% of the, sorry, let me rephrase that again. So it can remove 91% of the memory or storage needed and still remain the data of the CSV file inside Parquet. So this is the best when it comes to compression rate. Next, it's about the compression duration. So you can see Botley is the worst compression algorithm and the worst decompression algorithm when it comes to the Parquet algorithms. And worry not, this is not a big issue when I show you another slide comparing between 7Z and zip files. So in this slide, it's about ranking the best common method and ranking the best Parquet algorithm. So you can see over here the compression rate is 88% for 7Z and 91% for Parquet. And by by judging this mathematically, we can say that Parquet is the superior approach when it comes to handling the CSV data than 7Z. Next, it's about, yes, this slide is very important because just now I have mentioned that Broadly is the worst algorithm when it comes to compression duration. Sorry, this slide first. Okay, but you can see in the big picture, it wins the 7Z by a landslide, okay? And it is still better than 7Z. This is for compression duration, and the same thing goes for decompression duration. So back to the compression size slide. So you can see over here, it has no competition. It is the best compression algorithm amongst the Parquet algorithms, and it is the best approach when it is comparing to traditional approaches. So we have finally come to an end of our presentation, which is comparing actually what is the best method to manage our data inside a server. And if you pay attention enough, you will obviously know the winner of that. So let's put it in the even weightage where, oh, I have the matrix of storage reduction, compression duration, and decompression duration. So let's say that you value three of these metrics evenly. So fair enough. It's a 100% divided by 3, which will get you around 33, yes, 33% of weightage in the different matrix. So you will plug in the score of the individual matrix and times the weightage and add up the values of them, and you'll get a final score of 93 for Parquet. So this goes to show you that Parquet is better than 7Z or zip. Okay, let's say you want an uneven weightage. Let's say that in this case, you value storage reductions the most. You absolutely want the maximum value uh, for your server to store the absolute best content only. So storage reduction is the thing that you will be focusing solely on. So over here, I have done the math, and you can see over here, Parquet once again score the best out of the completion. So this is the last slide. I do not prepare, I don't need to prepare the slides where the weightage is 100% for compression duration or decompression duration, because it is also Parker will win by a landslide. And yeah, that's it. So hope you guys learn and something from this sharing session. So if there's one thing that you can take away, is that if you have big data, always use Parquet, because you are a very excellent data engineer that is taught by me. Okay, I gotta go. Bye bye. Thank you.